Okay, so we're gonna do this one the exact same way as the previous one we just did for number 3. So this is for problem number 4, where we have the hot dog cart on top of this 50-meter hill. It is actually already moving, they say in the problem, at 8 meters per second. It rolls down this hill and then on top of this hill, and they want to know how fast it's going here. So in other words, if I write this, they want to know the final velocity at point B. So we're going to set it up the same way by beginning like this, that the mechanical energy initially in the beginning is equal to the mechanical energy in the end. So then, just like before, the next line would start to become something like this. The initial gravitational potential energy here plus its initial kinetic energy at point A has got to equal its final gravitational potential energy plus its final kinetic energy. And so now think about if it doesn't actually have any of these. Well, it's got gravitational potential energy up here on top of the hill, and it's already moving, so it's got kinetic energy there. And it's going to be moving when it gets here, and it's got gravitational potential energy there as well. But there's actually a little trick you can do here, and it makes things a little bit easier, is you get to pick what is the ground. So I'm actually going to make point B right here the ground. And why would I do that? Well, that means if this is what we're going to call the ground, then it has no height here. So it has no gravitational potential energy. So this part right here will drop out and we don't have to worry about it. But there's a little tiny trade-off you got to do there. So if B is the ground, then this hill has a height of 0. But this initial hill over here isn't 50 meters tall. You just look at the height above the 30. So this hill is really 20 meters tall. And so that little change from 50 to 20 makes this problem overall a little bit easier because we don't have to worry about that term right there. So now, next step, let's plug in for each of these terms here. So gravitational potential energy will be mass times gravity times the initial height. And the initial kinetic energy will be 1/2 times mass times initial velocity squared. Don't have to worry about the final gravitational potential energy. And the final kinetic energy is 1/2 times mass times final velocity squared. So, just like we had on our previous problem there, the masses are involved in every term. They give you the mass, they say it's 300 kilograms, but it doesn't matter. You could put it in there, but you'll get the same answer either way. So now let's start to plug in with all these numbers here. So acceleration due to gravity is 10. The initial height, remember, is going to be 20 meters, not 50. And then 1/2, they gave us the initial velocity. Up here, they said it was going 8 meters per second to begin with. So we'll plug our 8 in for our initial velocity. Don't forget that it's squared. And then we're looking for our final velocity. Don't forget that it's squared. How fast is it going right there? So now we can start to do some of these numbers. 10 times 20 is 200. 8 squared is 64. Half of that is 32. And so then add these two together. 232 is equal to 1/2 times final velocity squared. I'll multiply a 2 by each side to get rid of that half. So we'll get 464 is equal to final velocity squared. So final velocity is equal to the square root of 464, which is about 21.5 meters per second there. And so that is how you solve that one.